All right, so we are going to divide radicals today. Now, normally, whenever we teach multiplication, you think we would teach division with it, but there's a little bit more to actually dividing radicals. So, the good news is the rule is very similar to what it is with multiplication. So, what was our rule with multiplication?
Radical plus radical.
Outside times outside, inside times inside. That is also true with dividing. It just looks different because instead of multiplying, they're on top of each other. So the rule is, if you have the square root of a number over the square root of another number, that's fine. But if you can rewrite it to where it actually reduces, you're welcome to do that. Now, what was one of our rules about having a fraction under the radical? You can't have a fraction under the radical. So regardless, if we have this, so if we have this little second part, we may have to actually break it up. Now, I think it's more confusing to look at that, so we're going to look at as many problems as we can. So if we look at this first example, we have a 6 under a radical over square root of 3. Can you divide those?
Yes.
Can we legally divide them the way they are written right now? Absolutely, because they are both under radicals. So what does that simplify to? The square root of 2. Now, just like with multiplication, you should always check to see if that number simplifies, which obviously it doesn't in this case. Same thing here. Somebody divide 720 divided by 12 and see what you get. 60. So since they're both underneath the radical, this breaks down into the square root of 60, but is there a perfect square inside of 60?
Oh, yeah.
What? 60 divided by x and your y equals, if you don't know, and look at your table. 4 times. Yep, 4 times 15. So this simplifies to 2 times the square root of 15. And then on our last one, and this one is not simplified because we have a fraction underneath our radicals, and that was one of our rules that we couldn't have. So if it looks like this, you actually have to go one step further and say the square root of 5 divided by the square root of 9. How does that help us? Yes, now you can do the square root of 9, so your final answer is going to be square root of 5 divided by 3. Now I'm going to add one little thing to the slide because I want to show you a very common mistake that people make. If we have something like the square root of 6 divided by 3, can we simplify that any further?
Yeah.
How?
No,
But remember, they either both have to be outside or they both have to be inside. Now, if I change that problem to, let's say we had 6 times the square root of 6 divided by 3, could I simplify that? Yes, because I have a 6 on the outside. This 3 is on the outside, so that would actually simplify to 6 root 6. Okay, this is why division's on a separate day, because there's so many different ways it can look. Okay, and here's some more practice. So we're going to go through these together. So which parts can you simplify and which parts go together over here on number 1? So we could go outside. So what does 6 over 8 reduce to? So 3 over 4. And then what about the 10 and the 2 that are both underneath the radical? Be careful. 5. So where does that square root of 5 go? Yeah, so I would write it 3 times the square root of 5 over 4. There's nothing else we can do to simplify that. What should we do to number 2? Yeah, you should break it up. So that would give us the square root of 5 over the square root of 49. So we know we can't simplify this. But what is the square root of 49? 7. Is square root 5 over 7 good? Yep. Now, in this instance, you just have to be careful because what do you notice about 16 and 81? They're both perfect squares. Now, if you need to, you can absolutely write the square root of 16 over the square root of 81. And what would be on top now? 4 4 over 9, and that would be your answer. And then same thing for number 4. Now, is there, and I hate to even ask this because I really, does this reduce? Yeah, it does. So you have the option. You can reduce it while it's underneath the radical. They're still both going to be perfect squares. Let me double check that. Okay, it's 16. Perfect. So, but I personally would rather go, the square root of 4 is 2. The square root of 144 is 12. And I would rather reduce it when it's outside of the radical. So that's just my preference. We get into what are we going to do whenever we have a problem that looks like this. 2 over the square root of 3. Because right now, well, but you can't just leave it because what rule does that break? You can't have a radical in the denominator. And this is where these things that I call special ones, and it's kind of silly, but it's what helps me remember. What is 2 over 2? 1. 3 over 3 is 1. Anything over itself is 1. So if you multiply something by 1, does it change what it actually is? It does not. So we can multiply something by a special 1 to get this radical out of the denominator. And this is what our special ones are going to look like. Square root of 2 over square root of 2. We know that's just a 1, so if we had to multiply something by that, we're only changing the way it looks. We're not actually changing the values. So let's look at when we would have to use this. 4 over the square root of 5. Right now, you have no idea how to get that radical out of the denominator, but this is where your special one comes into play. Whatever radical, and you can say whatever most simplified radical is in the denominator, that's how you're going to know what your special one is. So because I need to get a square root of 5 out of the denominator, I'm going to put it on top of itself and multiply top times top and bottom times bottom. So what does this top become? One's outside, one's inside. So you just have to stick them together. 4 root 5. Now, here's where I'm going to kind of show you a trick. What is the square root of 25? Oh, hang on. What is the square root of 5 times the square root of 5? The square root of 25, which is just what? 5. So notice, if you multiply square root of 5 times square root of 5, what comes out? Just a 5. So I'm trying to teach you a shortcut. Yes, so look, here's a good example. If I do the square root of 2 times the square root of 2, it's just going to be 2. If you do the square root of 6 times the square root of 6, it's just going to be 6. Okay, it's just a very little handy trick. Did somebody have a question? No? Okay, let's do this one. What should we do first on this one?
Break it up.
Yeah, break it up. So we're going to break that into the square root of 3 divided by the square root of 50. Now, yes, and that's what I was actually fixing to say. I would use the smallest number possible as the special one. So if you can break up this denominator, do it. So 25 and 2. So this denominator, the top stays the same. And what's the denominator going to become? What comes out if you have the square root of 25? 5 times the square root of 2. Now here's one more thing. When you pick your special one, do you have to include that 5 right there? No, don't, because it's going to make you have to reduce in the end. So what is our special one going to be in this case?
2.
Don't just say 2. Square root of 2. Yes. So square root of 2 over square root of 2. So what's the top going to become? What is the square root of 3? Okay, they're both under. So square root of 6. Let me give myself more room. Hang on, y'all are almost there. Or I'm almost there, y'all. Let me catch up. Square root of 6 over. Now here's where you can use that trick again, but you just have to be careful. What is the square root of 2 times the square root of 2? No, not divided by, multiply. It's just a 2. So what's 2 times 5? 10. Is this simplified? Yes. Why can't you reduce the square root of 6 and the square root of 10? Excuse me. Yeah, I said it wrong. But yes, the top has a radical, the denominator doesn't. So that's as simplified as it can get. So if you look at this first one, what was your special one? Don't say 2. Square root of 2 over square root of 2. So on top you have 2 square root of 2 over, what's square root of 2 times square root of 2? 2. Now check your outsides and your insides. That's the best way I can say it. So do you have anything that can reduce on the outside? Yeah, 2 over 2 is just a 1. So you end up with your answer being just the square root of 2. Now, number 2, we really need to look at it several different ways. Can somebody raise their hand and tell me one way that they did this one? Yes, sir. So you said the square root of 9 over the square root of 75. Mm-hmm.
And then square root of 9.
Okay, so you change that to a 3. That's good.
And then I did the square root of 75 and 25.
Okay, 25 and 3, so that would be 5 root 3. Oh, well, yes, but you have to, I'm going step by step. You have to finish this. So now you've got this, and then you picked your special one. So then you did times root 3 over root 3. So what did you end up with on top?
Well, I got 15, so I even had 5.
Well, you do, but that's in the bottom. You do. So let's look at the top. So you have 3 times root 3, which is just 3 root 3, divided by, now you have 5 times, what is root 3 times root 3? Just 3 times 5 is 15. And then when you check your outsides, does anything reduce? Yes, they will both reduce by 3. So you end up with 1 times root 3 over 5. Do you have to put that 1? No, you don't. No, you don't. Always check to see if it'll simplify. And if you're not sure, stick it in your calculator, hit math, enter, enter. So 9 divided by 75, enter. Oh, great. 9 divided by 75, enter. And then math, enter, enter. So before you ever even start this thing, you could go ahead and reduce this. You could say the square root of 3 over 25. Then you could break it up. Square root of 3. What is the square root of 25 in the denominator? 5. If that doesn't make you want to check to see if your fraction's reduced, I don't know what will. Because look at all of this work compared to if you reduce it first. Either way, you're going to get the right answer. One's just a lot shorter. Not just 2. Oh, it's not even 2. Be careful. It's the denominator. So times the square root of 3 over the square root of 3. So what does the top become? Square root of 6. 2 times 3 are both under the radical, so that you can put it under the square root of 6. And then what is square root of 3 times square root of 3? 3. Can this be simplified? No. No, it's not the, it is the lowest as far as the lowest on your fraction, like the bottom. No, it's the bottom. It's always your denominator because that's what can't be the radical. Then real quick, if we do number 4, because we still have to get to conjugates, this is going to be the square root of 5 over the square root of 5. So 1 times square root of 5 is square root of 5, and then square root of 5 times square root of 5 is just a 5. That is completely simplified. The last thing we have to do are talk about conjugates, okay? Now, I like the word conjugate because it's kind of different, so usually we remember this kind of stuff. Hopefully we will, because you will definitely see these again in Algebra 2. Right now, do you have any idea how to simplify 3 over 5 plus square root of 2? Well, the thing is, we have yet to have a binomial in the denominator. So we have only had monomials, or just something multiplied together. We can't have that plus. We haven't dealt with that plus yet. No, but I think what somebody was saying is you could split it, but you can only do that if you're dealing with a binomial in your numerator and a monomial in your denominator. So here's where conjugates help us. And just like in the problems before, it was really easy to know what your special one was, right? Well, it's really easy to know what your conjugate is too. So just like before, how we multiplied by something, this time we're going to multiply by what's on the bottom, except we're going to change the sign. So our special one is going to be 5 minus the square root of 2 over 5 minus the square root of 2. This is the conjugate of that denominator. Okay, all you have to do is change the sign. There's a little bit more work involved to these because what do you have to do to this 3 to that special 1? You have to distribute. So 3 times 5 is 15. 3 times negative square root of 2 minus 3 square root of 2. And then we have to do what in the denominator? Well, they don't just cancel out. What do you have to do if you have a binomial times a binomial? Double distribute. Okay, so let's double distribute. So we've got 5 times 5 is 25. 5 times negative square root of 2 is minus 5 square root of 2. Now I'm going to come from the second term. Square root of 2 times 5 is plus 5 root 2. And then finally a positive square root of 2 times a negative square root of 2. What is square root of 2 times square root of 2?
Negative 2.
It's just a 2. Because it should be square root of... Yes. Okay, what happens to those middle terms? Did we get rid of our radical in the denominator like we needed to do? Yes, so that's what the conjugate does for us. So our final answer is 15, well I say our final answer, I have to look at it. 15 minus 3 square root of 2 divided by, and then if we simplify the denominator, that's going to be a 23. So the whole goal was to get the radical out of the denominator, and that's exactly what we did. Now, I do want to point out one thing, that this number, and this number, if those were all reducible by the same number, you could reduce that. So let me write you in a little example over here. So let's say we had 6 plus 3 root 2 over 9. So notice, look at the numbers that I circled over here, and let's circle them over here. Do those all reduce by the same number? Yes. And I personally think it's easiest to kind of, so what, they all divide by 3. So what's 6 divided by 3? 2 plus what's 3 divided by 3? Goes away, so square root of 2. And what's 9 divided by 3? 3. So in the blue is what that extra problem simplifies to. I just want you to be careful whenever you see stuff like that. So we're going to do one more together, and then you're going to do 5A by yourself. So you do need to check and make sure everything is simplified, or as simplified as it can be, and it is on 5B. So what is our conjugate for 5B? Yes, don't make it hard. It's whatever's in the denominator. So 3 plus the square root of 7. 3 plus the square root of 7. Oops, I put a 2. Now on top we have to distribute. If it helps you to put parentheses around that, do it. So we have 7 times 3, 21. 7 times square root of 7 is plus 7 root 7 divided by, here we have to double distribute. You need to put parentheses, or if you want to do some side work, that's fine. So we have 3 times 3 is 9. Then we have 3 times square root of 7, so plus 3 root 7. Then we have a negative square root of 7 times 3, which is minus 3 root 7. And then finally, negative root 7 times root 7. What is that? They don't cancel out. And if you really need to, you can write minus square root of 49, but that's really just minus 7. Okay? So what happens to your middle term?
Cancel out.
Yeah, the middle terms do cancel out and gets rid of our denominator, or our radical in our denominator. So you have 21 plus 7 root 7 divided by, what's 9 minus 2? 2. 9 minus 7 is 2.